Hi everyone, this is Ria from Castle Island Ventures. Today we had the privilege of hosting Starkware co-founders Ellie Ben-Sasson and Uri Kolodny in the next episode in our modular blockchain series. Starkware is leveraging Stark proofs or validity proofs to unlock a magnitude increase in computational scalability via Starkex for application-specific execution and the public Starknet for general purpose execution, while simultaneously working on integrating the two systems to create a three-layer stack that offers security but also control or sovereignty in designing the computational environment should apps so choose. We cover how Starkware intends to do this, as well as the advantages and challenges of architecting a new programming language that's optimized for zero-knowledge rollups and validity proofs, how Starkware enables functions and applications that couldn't previously be built on monolithic layer 1s, the different approaches to data availability, as well as the trade-offs of each, and how computational integrity and inclusive accountability go hand in hand, among many other topics. Ellie and Uri answer my most basic questions while also breaking down more technical concepts in a really easy to understand manner. So let's turn it over to the conversation with them. Welcome back to On the Brink. This is Ria from Castle Island Ventures, and today I have the pleasure to host Ellie and Uri from Starkware on the podcast for the next episode in our modular blockchain series. First of all, congrats on your recent fundraise, and thanks so much for joining us as the next guests in this series.
Thanks for having us.
So I actually remember writing about Starkware back in March of 2019 when I was at Circle working on Circle research. And I think back then you were working on Starkdex with 0x and StarkPay and exploring how Starks can be applied to different applications to increase scalability. So it's really awesome to have you on, and it's incredible to see how Starkware has grown and evolved since then, and really found a killer use case for Stark proofs and validity proofs and rollups, all of which we're going to get into. But before we dive into Starkware, as well as before unpacking some of your views on the modular blockchain thesis and landscape, can you both quickly give us an intro, what led you down the zero-knowledge cryptography path, and how did you ultimately find each other and decide to build Starkware together?
I'll start with the find each other. So we found each other, for better or worse, more than 30 years ago. We're good friends since a long time. And so that's how we found each other. So we studied computer science together. We knew each other even before that. Uri went on to study business and be an entrepreneur, and I dabbled with math, which is how I ended up doing research on cryptographic proofs. Initially, all in the field of mathematics and theoretical computer science, but at some point, I started veering a little bit into academic implementation of some of these systems. And then in 2013, I swallowed the red pill of blockchains at the Bitcoin conference in San Jose, where I realized that actually this technology of cryptographic proofs can be tremendously helpful in blockchains, both for privacy and for scalability reasons. So immediately after that, with colleagues, including one of our other co-founders, Alessandro Chiesa, both he and I and a bunch of others were on the Zcash founding team, which is based on a very cool cryptographic construction called the ZK Snark. But we continued doing research with another of our co-founders, Michael Ryabtsev, who was my PhD student at Technion. We came across a far better and more future-proof and scalable technology called ZK Starks. And then it was time to put this technology to good use. And so, no better co-founder than my very good old friend Uri. And so that's how we got back together.
Ellie, you brought up snarks, which are the proofs that are used by Zcash. I want to go back to the basics for a second. Could you quickly go over what is a Stark proof? What is a snark proof? How do they compare and contrast? And what are some of the trade-offs?
Yeah, so I won't go into the very intricate math of either of these, but I'll try to give some very high level and inaccurate explanation of the difference between the two. So there's this beautiful story called The Empty Pot, which is a story about integrity. And in it, the emperor hands over seeds to children in order to grow a flower, and the child with the most beautiful flower will be picked to be the next emperor. Well, all children come back with beautiful flowers, but for one, this one child comes back with an empty pot, and lo and behold, this child is elected to be the next emperor because the seeds that were given to the different kids were all cooked by the emperor, and only one child operated with integrity and returned with the honest result. So this story actually describes a little bit how snarks work. In the world of snarks, there is some secret that is baked, and everyone is given these seeds that come out of this bake-off. And then if you operate with integrity and correctly, you can get a valid snark proof. Now, Starks work differently. There's no secret, there's no trusted setup, there's nothing like that. It involves a different kind of math and is more like polling an election. You can poll the correctness and integrity of a computation. So that's the core difference between Snarks and Starks.
Okay, great. That's definitely the first time I've heard that analogy, but I think it did a really great job of illustrating the core concept, at least. So initially you were working on using Starks to scale specific applications, and you still are via Starkex. Could you talk a little bit about how you're applying Starks to application-specific use cases and how you've unlocked scalability to date for applications like DYDX, ImmutableX, SoRare, and so on?
Sure. So we started out by introducing Starkex. It actually went live on Ethereum mainnet exactly 2 years ago in June of 2020. And we started out with a simple use case for our scaling solution. That's spot trading. So Starkex out of the box supports a bunch of use cases that have grown over time as we encounter new customers with new business logic and new needs. We gradually expand the scope for Starkex. And in order to do that, in order to allow Starkex to support these different use cases, I'll just sort of quickly run through them. So, Diversified does spot trading. DYDX, of course, does perpetual contracts. SoRare and Immutable do minting and trading of NFTs. Seller recently launched a DeFi pooling service, and there are a bunch of other folks in the pipeline building and about to launch with these different use cases. All this is powered by a language that we actually developed at Starkware. That language was developed as a necessity. It's called Cairo. You may have heard of it. It was developed as a necessity because up till that point, in order to represent, to generate a proof for a particular sort of logic, particular computational statement, we had to basically design its own set of to represent it mathematically with a set of polynomial. We won't go into the nitty-gritty details, but representing a given piece of business logic, a given computational statement, in a form that would allow us to generate a proof for it, was, prior to Cairo, a very dangerous task, a very complex and dangerous task. Dangerous in the sense that you could easily, in the process, end up proving a slightly different statement than the one you intended to prove. And that, of course, would be bad news. So in order to avoid that, we invented Cairo in-house, and that powers Starkex. But then the sort of the next logical step was to say, hold on a second, instead of Cairo being used strictly by Starkware folks, let's open it up to the world. And that's how Starknet was born. Starknet is a permissionless rollup. It's been live on a public testnet since June of last year, and the alpha went live on mainnet in November, and it's developing very rapidly. And there's an astonishing amount of developer interest in sort of exploring all sorts of applications and tooling around Starknet.
So you actually brought up one of my questions, which is that there's this challenge that's been raised when it comes to zero knowledge rollups around EVM compatibility. Is that what you were referring to? Is that the crux of it, which led you to build or develop Cairo?
No, so EVM and Solidity is of course the software stack that Ethereum and a bunch of other chains runs on. We concluded when we started to build Cairo that insisting on being EVM compatible would of course serve one particular need, and that is to be able to address the needs of the Solidity community as it stands today, but being able to actually sort of rebuild from a clean slate would allow us to build something which is much more performant and bring to market something much sooner. I mean, the proof is in the pudding in the sense that there are a bunch of folks who have been talking about various forms of ZK EVM. We have been on a public testnet with proofs since June of last year, as I mentioned. These other folks are not, I think, not anywhere near a public testnet, let alone mainnet. And the reason is that it's a very hard problem that they're trying to solve. What we see, in fact, it was far from certain when we launched Starknet, but what we've seen since is that developers are actually perfectly happy looking, trying, and in fact building out a new tool chain to the extent it offers them a new capability. And Starknet provides developers a completely new set of tools in the context of the blockchain. It basically does away with sort of the gas limitation paradigm as Solidity developers have sort of been brought up to live by. That has been the dominant constraint for Solidity developers essentially since day one. And in Starknet, that is to a dramatic extent no longer, or will at some point will become a non-issue. And that gives rise to a whole bunch of applications that no one would ever dream of deploying on an L1. We see that over and over and over again. We had a hackathon a few weeks back in Amsterdam. One of the most beautiful things to watch was that all the looking at sort of the finalists, half a dozen finalists in the hackathon, they all did stuff that conceivably would be impossible to do on layer one. Meaning it's not that we came to the hackathon and what we saw was people building more scalable, more performant variations of what was already previously built on layer one. What we saw was sort of a fresh start and an attempt to innovate in all sorts of exciting ways.
In your situation, building like a purpose-built language for Starknet actually allowed you to kind of move faster. Many might have heard that it's difficult to implement general purpose smart contracts within a ZK rollup. Is that and you've kind of managed to address some of those challenges and deploy Starknet so quickly. Um, is that part of the reason? And then could you talk more broadly about why that's the case?
Yeah, so people who want to deploy smart contracts on Ethereum usually have to learn Solidity and write their logic in it. Not because there aren't better, more established languages like Python, Rust, or C++, but rather because Solidity is a language that is catering and built to satisfy the exact constraints of the system called Ethereum. Now, validity rollups and Starknet, based on the Stark technology as such a rollup, have a very, very different set of constraints. Some of them come from the cryptographic and mathematical nature of Stark proofs. Others come from other areas, but they have a very different set of constraints. And because of that, the best way to harness and reap the maximal amount of scalability in the fastest way um, in our judgment, has been to define a new language. So once we have this new language, which is in some ways a very minimalistic language by design, but once we had this bare bones language in hand, it allowed us, first of all, to write logic for amazing systems like DYDX and Sorare and Immutable X very quickly. And it also allowed us to write the logic for Starknet. So a new system, in our case, Starks, leads to a new set of constraints. And we thought that the best way forward is to define a new language that is suited to satisfy these constraints in the best way. And that's what led us to this feature velocity that we're now displaying.
One advantage that obviously EVM and Solidity have around them is the tooling that's been built for developers over the years. Is Starkware developing tooling around Cairo internally, or are you working with teams to kind of build a similar stack that makes deploying code more seamless for developers?
So that's a terrific question. The good news is that tooling that was to a great extent non-existent, say 6 months ago or 9 months ago, is moving very, very rapidly. So just a whole bunch of and we're extremely happy and encouraged by the fact that this is a community effort in the most sort of organic of ways, meaning a whole bunch of teams outside of Starkware building rather frantically. So just to give a bunch of examples, so let's see, 3 full node efforts, a block explorer, Snapshot yesterday announced their indexer, Lambda class a couple of days ago and announced their Rust implementation of the Cairo virtual machine, half a dozen auditors, um, um, I mean, left and right, there are people building libraries, there are people building tooling for facilitating the formation of applications on Starknet. And, it's initially we were sort of the coordinating sort of point in this effort. But right now they're running fast and on their own. I forgot to mention a couple and counting wallets. I forgot to mention multiple Oracle efforts. Some of them native to Starknet. Also on the wallet front, both teams migrating from other chains and native efforts on Starknet.
So, taking a step back, it would be great to maybe walk through an example of what happens when a transaction takes place on an application like a DYDX or an immutable X deployed on Starkx from start to finish, and then compare that to uh, what happens or what will happen from start to finish when a transaction takes place on an application deployed on Starknet.
Okay, so the process is pretty similar. I'll specify it first for a Starkex system and tell you where the difference is now and going to be for Starknet. So as a user, you sign some transaction, and then your wallet signs it, and it's transmitted from your smartphone to some mempool. Now, in the case of Immutable X or DYDX, this mempool is actually managed by either Immutable X or DYDX. And at some point, there's let's say a settlement, or this transaction is actually processed by the operator and sequenced. So it is now, it's deemed to be valid, and it looks good, and you want to basically change the state of the system based on this thing. Suppose you sent, Uri an NFT, right? So we need to change the database to reflect that the ownership of the NFT has moved from you to Uri. Okay, so the operator does this change, and now this sequencer, which is right now immutable or DYDX, has a batch of such transactions, and it needs to be proved. So it's sent, this large batch of many, many transactions, including yours, is sent to a prover machine that is right now operated by Starkware. A proof is generated and then sent to the blockchain. The blockchain has a smart contract for a verifier, a Stark verifier. The verifier verifies the correctness of the proof, and now the system, the state of the system is updated. So this is how it works today. Now in Starknet, it's going to look pretty much the same. The only major difference is going to be that instead of having one single operator sequencer, which is DYDX or Immutable X, it's going to be like in Ethereum. It's going to be basically a network of nodes that any one of them can be the one who's processing and sequencing a large batch of transactions. And then the other change is that the prover as well can be, it's not going to be Starkware, it can be any other machine that is running a prover code and generates a proof for such a code. So instead of having DYDX be the only sequencer and Starkware being the only prover, in Starknet you move to a world where anyone can be the sequencer and anyone can be the prover. But other than that, the flow is the same, meaning security and finality are ultimately given by having a verifier on layer 1 Ethereum, verify a proof, and only then is the state of the system, the L2 or the Starkex system, updated.
Got it. I think one thing you mentioned during that explanation was that the sequencer waits to collect a batch of transactions before before a proof can be generated, so that the cost per transaction is kept low. So I guess how long does it take to accumulate a batch of transactions and then settle it or verify it on chain?
So that depends on many factors. And here again, Starkex and Starknet are going to look very different. So on Starkex, we let the operator decide at which frequency she wishes to choose to close a batch and start the proving. And then different customers choose different time periods. And then they also have different rates, the rate of transactions, and also the sort of the variance in the way transactions arrive on DYDX, for instance, are very, very different from Immutable X. Because to give one example, Immutable X services a lot of games, and often they have like a minting season, right? So during a very short time, you have huge throughput of transactions, and then it's much lower. Whereas DYDX is a trading system, so it basically varies with the trades. So to sum this up, on the Starkex systems, each of our customers who is an operator decides on the size. Now, in Starknet, it will likely look a lot more like Ethereum, which means that there's one block per some quanta of time. The exact size we don't know, and then different blocks are going to have different sizes. As you have more congestion, more transactions. So you'll see larger blocks, and then you'll see smaller ones when there's less. The big difference with Ethereum, or Bitcoin for that matter, are that currently we don't foresee any reason to put a limit on the gas size or size of a block, because basically as far as we can see right now, proofs can scale to deal with nearly any size of batch. So you could have very, very large blocks.
And is it correct to say that the amortized cost per transaction goes down as the number of transactions in a batch goes up? Could you correct me if I'm mistaken, and then explain that a little bit?
You said it exactly right. And it even goes down. It goes down to zero, so it converges to zero, the amortized cost per transaction, and it does so in an exponential way. So let me explain. The size of the proof is roughly logarithmic in the number of transactions. Well, so if we just work with base 10 logarithm, just for simplicity, the logarithm of 1,000 is 3. The logarithm of 1,000 is basically the number of zeros. So the logarithm of 1,000 is 3, which means that the size of proof would be, let's say, 3 units. Let's say 3 million gas, but now it's divided by 1,000 transactions. So 3 million divided by 1,000. Help me out here. 3 million, 1 million. It's 3,000. Okay. So taking this, if we have a batch with 1,000 transactions and you pay 3 million gas, it means that the amortized cost per transaction is 3,000. Now, if you have a batch with 1 million transactions, which is 1,000 times more, the logarithm of 1 million is actually 6. So if the cost of such a proof is 6 million gas, now the amortized cost, you paid 6 million gas, but you covered 1 million transactions. So the amortized cost has gone down from 3,000 gas to 6 gas. And with 1 billion, it's even better, because now you have 9 million gas covering 1 billion transactions, which is in the sub 1 gas per transaction.
I want to add to that. Maybe it's worth emphasizing that this property of our scaling solution, where marginal cost per transaction goes down as the scale increases, is a very unique thing. And maybe it's underappreciated that in the monolithic layer 1 solutions, and we've all seen this play out on Ethereum time and time and time again, and I think that we will see it in other layer 1 attempts once those start reaching capacity, or introducing fees for that matter. Once those systems reach capacity, marginal cost actually goes through the roof. Okay, these systems just they blow up essentially. And so this diminishing marginal cost is really a very unique property. And with recursion, what's interesting is that typically there's a trade-off between scale and latency. In our case, actually, these two will work in unison and improve at the same time. We will, by using recursion, will both improve scale and cut down on latency.
I was lucky enough to attend the Modular Blockchain Summit this year, and Uri, see you speak and introduce terminology around what you're calling Layer 3. So could you guys talk about what is Layer 3 and how does that fit into Starkware's plans to connect Starkex to Starknet?
Sure. So Layer 3... Layer 3 is a sort of a very simple concept. So why do we call the Layer 2s Layer 2? We call them Layer 2 because they rely on the security of Layer 1 of Ethereum. They make use of that layer to obtain security. And in the Layer 2, we essentially offer scale. Now, just like Starkex settles on Layer 1 Ethereum today, and just like the public Starknet settles on Ethereum today. And by the way, like other Layer 2s settle on Ethereum today, of course, Arbitrum, and Optimism, and ZK Sync, etc. In a similar fashion, you could think of what would happen to a system that instead of settling on layer 1 would settle on the public Starknet. And this conceptually could be thought of as moving one layer up, hence the name layer 3. So what would be the benefit of that? One obvious immediate benefit would be greater scale, lower gas per transaction. Gas per transaction is pretty impressive as it stands today. Just to remind our listeners, DYDX, we're talking about tens of millions of transactions. DYDX in production on mainnet is at 480 gas per transaction. Immutable and Sorare are minting NFTs at less than 10 gas per transaction. This is with off-chain data. DYDX is with on-chain data. So already gas per transaction is very, very low. But layer 3 will improve that further. But I think that the interesting property, and if you were there in Amsterdam, Ria, then apologies for the replay. But I think the interesting story there is actually around control. Allowing applications to have better control of the environment that they operate. And what we've seen, and this is not limited in any way to, say, Web 2 companies that come in with all sorts of business models and constraints and practices where they have a stronger preference to maintain control, relative to native Web3 applications. This is also true for Web3 applications. They need control. They need control over the environment in which the computational environment that they operate. Specifically, they really don't like noisy neighbors. And the beautiful thing about noisy neighbors is that we all think of our neighbors as noisy neighbors. And of course, that holds for all of us, right? So we're often the noisy neighbors, right? So if Bored Apes are minted on the other side of the chain, that suddenly is noise for the DeFi folks. And if Uniswap is blowing up, then the NFT players are looking around and saying, well, what's all the commotion? Applications need control over the computational environment that they operate, and they don't like noisy neighbors. It gets in the way of business. It disrupts the UX. And I think that layer 3 is going to be the environment where applications come to thrive. This is a rehashing, in a way, no pun intended, of concepts like app-specific chains, side chains. Cosmos Universe had these concepts, Polkadot, etc. One huge differentiator here is that these layer 3 environments all eventually, going all the way down, rely on Ethereum's security. And as we saw, say, with the Luna meltdown, and this has nothing to do with the Ponzi-esque nature of that story, but as we saw with the Luna meltdown, a sidechain that relies on its own token price for its security, that presents a very precarious position when that asset tanks in value.
So I just want to make a clarification here. I'm kind of going through this exercise with you guys. So deploying an application on this layer 3, the execution takes place in the L3, the computation takes place in the L3, and then the proofs would be settled to Starknet. Is that right?
Correct.
And then that's distinct from deploying an application directly on Starknet, where the execution is taking place on Starknet as well.
I like to call it the public Starknet in the sense that we fully expect, in fact, we're in the process of developing these solutions with design partners and applications. We fully expect to find custom Starknet deployments in layer 3. So at this point, retro naming the layer 2, we call it the public Starknet.
Got it. Okay, that's super helpful. So since this is an episode in the modular blockchain series, I'd love to get your take on the full stack. We talked about Starknet, which is the general public execution layer, and I'd love to get your thoughts also on data availability and consensus and settlement. But before we do that, could you explain why data availability specifically is necessary and important and crucial for zero knowledge rollups or validity rollups specifically?
Yes. So validity rollups and things like Stark proofs, they really speed up the process of verifying and checking the correctness of a computation. And they do so by an exponential factor, which is great. However, directly, they don't apply at all to any compression regarding storage. Meaning that if so like you have a situation where you have a technology that completely resolves or almost completely resolves or drastically improves, exponentially improves one aspect of what a blockchain is, which is computation, but does very little to resolve other bottlenecks, in particular storage or consensus. So that's why you need some solution for limiting or pricing in the right way, or finding other means for expanding data availability on a validity rollup. I mean, otherwise you'll have to really scale up a system. It's not enough to open up one bottleneck. You have to open up all bottlenecks. So validity proofs are opening up one bottleneck of computation, but you still need to address the other bottlenecks like data availability.
But fundamentally, why do you need data availability for validity proofs?
Because otherwise, you will be in a situation where state will be forgotten. So, for instance, suppose my account is some information residing in the state of the system. Okay. Now, the validity proof aspect means that no one can steal, take my funds and put them elsewhere, right, without my signature. But the system could simply forget and lose the information about my account. Like just no one knows anymore what is the key, the public key of my system, and where exactly it sits in the system. And then, even though it's a lesser threat because it's not one of theft, it's one of loss, it still is a big problem, right? We don't want to be in a world where the system tells us, oh, sorry, we just don't know where your funds are. No one stole them. We can promise you that no one stole them, but no one knows how to retrieve them, right? That's not good enough.
Ria, if I understand correctly, you're asking why conceptually is there a need for different data availability solutions with validity rollups?
That was my next question, but what Ellie said just now is what I wanted to get at, because I think there's this misconception sometimes that you don't necessarily need data availability because you verify everything and then post the proof on chain. So what is the purpose? And it's kind of exactly what you said, Ellie. So yeah, let's kind of segue into the next question. You both mentioned this now, and I think also it was a takeaway from my conversation with Nick from Celestia and John about Fuel Labs, is that to unlock orders of magnitude increase in scalability, you need to optimize both the data availability and the execution layer for scaling to unlock the full power of rollups. So rollups specifically post both the proofs and the data behind the proofs on a single layer, like
Correct.
Ethereum.
Yes.
Right?
Yes.
And then there are different permutations around storing proofs on chain and storing data elsewhere, either off chain or on a different chain. Could you walk us through each of these structures and then the pros and cons of each one?
So maybe I'll start with the motivation. The motivation, I think, is rather obvious, but worth mentioning. Chains, whether layer 1 or layer 2 or layer n, doesn't matter. These chains are a public utility and a very scarce resource. Now, this is a resource that typically the different players compete for it in terms of gaining access to this, determined by market pricing. And so you may well find a situation where your application, because of the value of the assets, etc., is priced out of this scarce resource. And now the question is, what do you do, right? So you could say a Bored Ape worth $1 million, can easily reside on chain in terms of its owner's ability to spend the gas on that. But an NFT worth $1 may completely, very readily find itself priced out of the market. And so that data needs to reside somewhere, and that could be all sorts of different solutions. We think data availability is a very rich design space. We've had Validium, which is the off-chain data availability mode, where data is stored by a committee of reputable entities who sign per batch, who sign that they have the most recent data. And their commitment to the public is in case the applications operator and the proof generator, say in this narrative, that would be Sorare and Starkware, or Immutable and Starkware. If those suddenly are unresponsive, then the committee members' commitment to the public is to post the data in a public place. By the way, not on chain. Many people interpret that to mean on chain, but no, they can just post it on their website and allow anyone to access their vaults in the system and get the Merkle path from those vaults to the most recent Merkle root of the system. Take that Merkle path to the smart contract on-chain to retrieve their funds. So this is off-chain data. It's not as secure as on-chain data. It's, of course, not as expensive. And we find a very decent compromise. In fact, actually, it's not that we find. Starkex out of the box supports multiple data availability modes. Our customers find that this is a very decent compromise. The coming versions of Starkex, this is actually the very next version of Starkex that will be deployed on mainnet in a couple of weeks, will be supporting Volition, which is this hybrid mode where the choice, instead of being in the hands of the application, whether it wants to operate with off-chain data or off-chain data, that choice actually is handed over to the user at the single transaction level, which makes it, I think, a lot more fun. So, I keep, this is going back to my childhood, but, if you have the, it's not only that if you have the Mona Lisa, you want that on-chain and you have some, cheap NFT, then you don't mind that residing off-chain. If you've won the golden ticket in Charlie and the Chocolate Factory, that thing started its life off-chain, but once you realize that it's very valuable, you can now transfer it on-chain.
Got it. So you as Starkware are kind of agnostic to the specific setup, and
Exactly.
in the future when Ethereum is more optimized as a data availability layer and Celestia launches, and then there's more progress on Validiums and data availability committees. The choice will be left up to the user.
Exactly. When we came out with Validium, we were attacked left and right. There was a lot of pontificating going on. We found that to be completely irrelevant. Blockchains are a tool that serves users, not the other way around. And our business is to build something that is of utility to as broad a number of users as possible. And it's just by definition, not all data can go on chain. And so the question is, how do you solve the problem for everyone else?
Do you think that introduces complexity from a UX perspective? Obviously this is theoretical right now, but how do you hope and envision that looks like in having the choice as a user and having to understand maybe the trade-offs of the different options available to them?
So at the most sort of mechanical level, I don't think that is a huge UX challenge, in the sense, imagine a gaming application, etc. So you can have the safe vault more expensive, the lesser vault less expensive, but communicating to the to users, whatever, kids playing blockchain-based game, exactly the significance and the implications of the different solutions. I think that's going to be trickier. But if we're honest about this, we often are faced with situations where I don't think we fully understand. We don't fully understand the difference between being deployed on multiple GCP and AWS zones or not in terms of assessing the risk, etc., and the risk benefit trade off. We just sort of get used to sort of living with that degree of uncertainty. I'm guessing that in this context, that may well be the case. It could be that professional users, high frequency trading firms, etc., develop a much more intimate understanding of these trade-offs. But I suspect that teenagers, for good reason and fortunately, will remain teenagers.
You mentioned a few times that Starknet kind of unlocks the ability to build applications that we haven't even been able to dream of deploying to monolithic L1s. It would be great if you could talk about a few examples of what some of those applications are.
Yeah, sure. So there's mind-blowing stuff, right? So I for me, the first time so there's a wonderful Starknet OG by the name of Guilty Gyoza. He goes by Guilty Gyoza. That's his handle, and he's building all sorts of tooling for gaming. By the way, it was also for physics simulations that rely on Starks, basically giving verifiable computation in that domain. Now, what could that mean in terms of verifiable computation on the blockchain is a wonderful question. I don't think we're even scratching the surface there. But I keep reminding people that in the context of Ethereum, computing on-chain a moving average on Ethereum is an exceedingly expensive exercise. So if you come from a world where computing a moving average is something that you handle with care, if you can now start considering what game mechanics you want to be verifiably computed and whatnot, you're in a very different realm. So that's one example in the area of gaming. Another more recent example, Fran Algaba put out Giza, which is this tooling for starting to build the stack for machine learning over blockchains. And here too, two very, very useful pieces of technology that no one could really conceivably combine up till now. Mm-hmm. And suddenly there's an intersection to these two circles. And people start saying, so hold on a second, where do I use machine learning and actually expect my users to trust me? Because if that trust requirement is menacing, is getting in the way of business, maybe we can turn that into verifiable computation.
I want to go back to one thing that Ellie, you brought up in the beginning, which is the use of Starks for scalability versus privacy. Mm-hmm. And I think there's a misconception right now that, people have been trying to change the terminology and say we should call them validity rollups or validity proofs and focus on that aspect. When does privacy enter the picture?
That's a terrific question. In my view, it's when the market asks for it. And there's this well-known paradox in which we all say, yes, we want privacy, but we're actually not really willing to pay the price of it. And this is also true in blockchains. I mean, if you look at the privacy coins, Zcash, Monero, Tornado Cash, and so on, the markets are not valuing them at such a high premium. And it's not like, they conquered the world and everyone's moving over to them. I think all of the top 10 coins, or maybe even top 20, none of them are privacy coins. So this says something. This says that the market isn't demanding this kind of privacy first. So now to answer your question, at least here in Starkware and at Starknet, privacy is going to be added when users need it. From a technological point of view and cryptographic point of view, making the Starks zero knowledge is a very simple process. And even today, even though they're not formally zero knowledge, the proof itself doesn't reveal all that much. What is much, much harder is to build a user friendly and usable system that has privacy ingrained very deeply into it. Just to give some examples, I think that a lot of exchanges and ramp-ons and ramp-offs or cryptocurrencies are probably not going to be well integrated with such things. You probably need ZK proofs to be generated on wallets, hardware wallets, and mobile phones, and so on. And to best of my knowledge, this isn't the case right now, and certainly is not the case with popular wallets such as MetaMask or Ledger or things like that. So any team that wants to deliver true privacy will need to tackle these things, and it's a very daunting challenge. So we at Starkware are focusing first on scalability, which is a much more burning need that everyone sees the value in it. We would love to be in a world where everyone demands and is willing to actually pay in like user experience and so on for privacy, but the reality is that we're not there yet.
What does the next year? What's the focus for Starkware for the next year? And where do you envision Starkware, Starknet, Starkex, L3s 3 to 5 years from now?
We're very practical. So the next year is a lot about making Starknet better. In terms of functionality, we're pretty happy with functionality it has, but then the phase we're now focusing on is increasing throughput, reducing latency, and so on, and reducing amortized cost per transaction even more. And right after that, it's going to be all about decentralization, which means getting this network of operators and provers. Within Starkex, it's going to be improving again the just a set of attributes and properties that Starkex system has for its customers, bringing them on to layer 3, integrating that into Starknet itself. But beyond that, ultimately what we're delivering is a new technology, a groundbreaking technology for integrity, which means doing the right thing even when no one is watching. And we strongly believe that the larger world of traditional financial institutions, healthcare, and so on, could benefit from these better technologies for integrity. So we think that either by some of these big players entering blockchains and wanting this level of integrity at scale, or by adopting Starks and similar technologies outside of the blockchain, we think it will go further than just blockchains.
These concepts of computational integrity and inclusive accountability have been in your DNA since the very beginning. So
Right.
very happy you brought that up. And very, very excited to see all of the innovation that Starkware unlocks.
Yeah, and it's really about, so blockchains are all about inclusive accountability, about basing trust on inclusively allowing everyone to know that everything's okay, and that limits scales and also privacy. And what Starkware is about and Starks are about is all about computational integrity at scale with no trust assumptions. And we deliver this through math. And math made accessible to end users. So our mission is integrity through math. Blockchain's mission is inclusive accountability and a basis of trust that is more democratic, fair, and inclusive. And the two go together really well. Like macaroni and cheese, I guess. No?
Exactly. And that is,
today it's cucumber and salad, or cucumber and tomatoes, something maybe better.
Yeah, exactly. And I think one thing that I tried to do in this series is like really define what true scalability means. And it's not just an increase in throughput, but it's an increase in throughput while being able to maintain that inclusive accountability. So
Precisely. Because if you just want to increase throughput, there's a very easy way. If you just want to scale, you can do that very easily at the cost of making things more exclusive. You just tell everyone, okay, go buy a computer and an internet connection that is 100x bigger, faster. And then you end up in the conventional world with Visa and Swift. So
Yeah.
that's an easy route. You want to still be able to rely on everyone checking things with their laptops and still have greater skill. That's the challenge.
Well, Ellie and Uri, thank you so much for coming on and going through all of those thought exercises with me to really understand the moving parts. It's been an absolute pleasure. I've been wanting to have you on for a while, so I'm very excited we can make this happen.
Thank you. Thanks for having us.
Ria, thank you very much. Greatly enjoyed this very intelligent set of questions.